All right, kids. Today we're going to learn not to get Soren started on topics that he likes to talk about. So, we're going to be talking about the Hawaiian Hotspots and their history and what makes them super sick. But in order to tell you about the Hawaiian Hotspots, we have to go back a little ways to the tectonic plates. Obviously, we all remember 8th grade science class with Mrs. Weckworth. Baller. Anywho, we've got our little tectonic plates, right? They move around on the map. That's why this over here, the little S shape fits in perfectly with this S shape in Africa and whatever, So we have our Pacific plate and our North American plate and whatever. They're all moving around, right? Makes the borders really uncomfy. That's why there's earthquakes over here in California. We all know this, obviously. I should hope anyway. Anywho, so they're all moving in different directions as a general rule, although most of them are moving this way, kind of like westish, except for most of these in the Pacific, which is moving south and also east. But convection, that's what makes it go, right? So you think, what could move this much mass of a plate of thing, Well, it's convection, right? So right down here at the bottom of the earth, right? Super hot, the inner core, the outer core, whatever. It's basically nickel and iron that's super, super hot and melted and kind of just sitting there. I don't know why it's so hot. Probably gravity. Somebody could tell you that. I don't remember. Anyway, it's super hot. We get a little cycle going, right? The hot air goes up, or not air, but liquid, the hot molten rock, magma, goes up, goes over, and comes back down, when it cools off. And that starts a little cycle thing. And we get a cycle over here, and we get a ridge. Now, there's a mid Atlantic ridge right over here. That's why we see this. That's why America and Europe are moving further away. That's why the S curve works, right? It looks like it fits together because it used to, but now there's this ridge right here. There's also the same kind of thing over here, and I believe there's one further. No, shoot, there's one over here. Now, the Pacific plate is moving this way. Yeah, okay, so the ridge, there's one, shoot, that's the wrong tab. There's one right here going all the way down. There's also one over here, right? The Pacific plate's moving away. The Australian plate's moving this way. Pacific plate's moving this way. They just kind of do their little thing. Pacific going east, Australian going west. There's a ridge right here, obviously. Now, on the flip side of that, since matter cannot be just destroyed, it goes back down into the lithosphere, asthenosphere, whatever, mantle. That's the one. And it subducts underneath the thing, right? So we have our little, especially over here is a great example, the Cascade Mountains. Beautiful spot. Great. I don't have a rock on hand, but I could find you one. Oh, there's one. Hold on 2 seconds. Creates andesite, right? Nice black and white rock. So the black minerals that you see in there, mostly biotite and mica, come from the ocean over here, the Pacific plate. Now, this is an oceanic plate, a lot thinner of a crust, a lot thinner. Like the crust is a lot thinner because there's just less of it. You have to put the water on top, whatever. So that goes and hits up against the thing. This is also denser because there's more material packed into a tighter space. Hits the North American plate, which is a continental plate, which is a lot thicker and a lot less dense. And we have something thinner and more dense and something thicker and less dense collide. And of course, the one that's thinner and more dense is going to go underneath. The one that's thicker and less dense is going to go over top. This one goes down so far into here that it starts getting subjected to the heat of the core and it melts. And then once it melts, it bubbles back up through and creates volcanoes over here, which is where the Cascades come from. And when that happens, you get this nice kind of rock that half black, half white. That it looks super cool, and it's just a really neat kind of rock. Andesite, if you don't know. Now, there's also andesite in the Andes. Funny that, huh? Wonder where they've got that name. So that's also the same kind of thing. You have the plate subducting, the Nazca plate subducting on the South American plate, bubbling up through the mantle and creating volcanoes, which then create andesite. So, how does this relate to the Hawaiian hotspot? Well, you see, the Pacific plate is heading southwest, right? Although not quite as southwest as it was before, which we'll get to that too. Stick around, folks, right? Now, where did this go? Here's another example of a hotspot. Now, if we zoom out here and we go in over here, I probably should have figured this out where it is before, but I didn't, so I think it's up here, though. Yeah, right here. Yellowstone National Park. The Yellowstone hotspot. Ever heard of it? Of course you have. We all remember that video in Weckworth's class now. That's the same type of thing as the Hawaiian hotspot, right? So, a hotspot. We get to the fun topic, right? The hotspot is, nobody really knows what exactly it is. That's the fun part. That's why I like them. But we do know that they stay in the same place. So when Spencer says that, quote, underground volcano moves next location, that is incorrect, because the underground volcano, well, not actually a volcano, doesn't move. The plate moves over the top. And I've got a great demonstration for you, right? Good Lord, that was bright. We take this, right? Here's our little flashlight. This is going to be our hotspot. It buzzes. Don't worry about it. Here's our plate, right? So imagine that here's Hawaii, right? The magma is bubbling up right here, creating Hawaii, one island of Hawaii. Now the plate's moving. All of a sudden, it's moved positions. The plate has moved, not the hotspot, the plate. And more magma bubbles up, creates the next island. The plate moves again. More magma creates a new island, moves again, moves again, moves again. Pretty soon you have a large chain of islands, right? Which is why you see in Hawaii, this long chain of islands, right? So this is, I forget what this is. This is Maui, whatever the biggest island is. That's the most recent island. So that's where all of the volcanoes are right now, is because that's where the hotspot is. So that's where all of the magma is bubbling up. So if you look at a map of the island of Hawaii, Kauai, I don't really know what it is, but either way, I'm pretty sure this is Maui. I have no idea, but all of the islands would be on this southeast side of the island, because that's where the hotspot is. The hotspot's bubbling up, creating spots of magma, which turn into this. Not quite sure what kind of rock it is. It's very cool. My girlfriend brought it back for me from Hawaii. Now, this, like Spencer said, is metamorphic rock, because metamorphic rock, hopefully you know this. If not, I don't know what to do. But, you just got to figure it out yourself. But metamorphic rock is you take a previously made rock, whether it's igneous or sedimentary, and you subject it to lots of heat and pressure, and it makes a new rock. For example, sandstone, subject it to heat and pressure, quartzite. It's awesome. Now, don't know what this is, but it's whatever basalt makes. Here, I can look it up. Green schist. Green schist right here. All right, so here is the Yellowstone hotspot, right? same type of thing. Here you can see where it's kind of been cruising up. You can see each of these circles is where the hotspot was at some point or another. So it's telling you dates right here: 16.5 million, 15 million, 12 million, 10.5 million, 10 million, 6.5 million, 2.1 million, and half a million years, right? And you can see that it's moving in a northeast direction from the map, assuming that this is north, which looks like it is, yeah. Yeah, I think so. So you can see that it's moving, but it kind of looks like it tapers and kind of like a parabola almost, which is my next point. Here is the history of the movement of the Hawaiian hotspot, but not actually. It's the movement of the plate over the Hawaiian hotspot, as our good man Spencer has generously pointed out. So you can see here that it was moving very fast south, right? It was moving at least far south, and not too much east or west, although a little bit east. And then at this point right here, I forget, I think that's 50 million years ago or something, 150, I can't quite remember, but 45, I'm not sure. Either way, it switches off to much further east, still a little bit south, but much further east. This is almost a, I don't know, 60-degree angle or something. So it's a big change from going from, that's more than 90. You know what I meant, 120. So it goes from very fast south and a little bit east to most of east and just a little bit south. And now, of course, down here is where we are today, over in Maui or whatever island that is, right? But you can just see that the plate was moving very far south down. I got this wrong. North, right? So the hotspot, it looks like the hotspot was moving south, but actually the plate was moving north and then switched over to moving west. Shit, I might have to redo this whole video. Nah, you just know what I meant, right? Realize it now. Don't worry. So, boy, that was bright. Here's our hotspot, right? We're going to be moving down this way and then over this way. Although for you it would be like this, right? But so that's the direction that the plate's moving in. Because it looks like it's the hotspot's going this way, but actually the plate's moving in the other direction. So it's kind of just weird like that. You just got to think about it in a different fashion, which is interesting to think about. So that's what I've got for you on Hawaiian hotspots. Although I'm sure I've got plenty more to talk about. I could go into a lot more. Yeah, I won't though. Just for you, it's your birthday. Anyway, that's all I'll subject you to. Although you probably won't actually watch this video, so that's fine. But just know that I made it.